So the question or the best thing these transformer does is they helps you solve one problem, which is how to find what is the next thing in a sequence, whether that is a sequence of an audio, sequence of a picture, sequence of a word, sentence. Good. That's the problem they are trying to solve, which is what is the next thing in a sequence, which can be sequence of sentences, sequence of audio files, sequence of pictures, so that we can have videos like Sora 2, VO, and all those models. Good. To write, LLM must translate word into a language they understand. So the first step to predict the next word in a sentence, you need to put things in a machine format. And first step of that is you put them into tokens. So I take whatever I got and I create these tokens. So now I have 6 tokens out of this sentence. Everybody same page? We take words, we convert them into tokens. But as somebody rightly said when I was talking to you, we don't understand words. We understand words, but machine don't understand words. We need a language in which machines can understand, and machine can understand only one language, which is 0 and 1s. Correct? So how can we convert this word work into some kind of 0 and 1s which have the context of this word? That's where embeddings comes in. So what is happening here is we are training that how this work comes across in different words and what is the kind of relevance this has to other words when we use the word work. You can see it in these sentences. We can delegate work. Work is so hard. Work, his dedication to work has impressed everybody. All those things. We are looking at work and we are saying what can go closer to it. How the work is related to the other words in English dictionary. And this data we already have. So we can train this on nearby words. If we can train this, then we can find work relates to office, work relates to at, work can be downtown, work can be project, but work and atmosphere, work and zebra, work and dove, and work and polka have no significance together. So we can find work and what work relates to and what work doesn't relate to by just going through a lot of text on internet. Can we all do that? If we can all do that, then we can put all this information as zeros and ones and encode that in a 2000 column matrix or this vector. And this vector can ultimately result what work would be. And we call this work or this vector as embedding of the world. So that's the first step. In any AI, you need to convert this words into something that machine can understand, which is numbers. But these numbers are trained based on how the work relates to other numbers or other words in English dictionary. So far, so good. You got 20% if you got embeddings. Everybody got embeddings? If you didn't got, just put some questions on chat or in your notebook. We will talk. We can come back to it. So now I have done the first step, which is I took the sentence, I converted it into tokens. For each token, I have created an embedding, which is this value. Then I have work, and I can find embeddings or the value of work. But then if I can do that, I can find the values of other words too. Sea, ocean, football, soccer. And you see one pattern here that the things which are common, which have a lot of things common, their embeddings, if you color code them, would look very close. Like sea and ocean look close, but sea and football doesn't look close. Because these numbers on each column, if I color code them from this pattern, then they are related because they show up together combined to other words. Good. So if I am training how sea and ocean show, they are showing closer by, and that's how I calculated these numbers in these columns. So these numbers embeddings look similar to the numbers that, or to the words that it came across or we have used before. Good so far. We have embeddings. Embeddings allows us to put the context of language in words, but in numbers, in numerical form, the words. And it also gives you this power that now similar words will have similar embeddings. If that's the case, then what you can do is you should be able to go and say, hey, if I put all of this on an XY axis, then I can see that the words that are closer will stay closer. Then I can cluster them also. So all pronouns in this are clustered together. All the motion verbs are here, and then nouns are here. And nouns also, the nouns which represent similar things are here, while the nouns that represent other things are here. So now machines can understand language. This is how machines understand language. They create embeddings, and once the embeddings are created, they could figure out which word is closer to what word, and that has a meanings of noun, also verbs, and also adjectives, but also how these other adjectives that we use, if they explain the same thing again and again, those can be clusters again. This is just two-dimensional. Generally, the embeddings have 2000 dimensions. Umesh is only following me. So I will just keep it following Umesh leads. Anytime he says thumbs up, I will keep moving. Okay. I think all of us are getting that. Embeddings to this kind of representation.